guys, welcome back to tutorial 2 on source transformation. In this tutorial, we are going to use the circuit here to calculate current I. I is the current through what? The 6 ohms resistor. So as you saw in the previous video, we are just going to change the sources, a voltage to a current, or a current to a voltage. So when you study this diagram, we have 4 sources. 3 of them are voltages. Only one is a current. So I would prefer to change the current towards a voltage only if it obeys the rules that current is in parallel with the resistor. If you take note. And I can see that this current here is parallel to this 4. So I can now convert this to this portion here and see what I'll get. So let's maintain the rest of the elements. We have a voltage here in series with this. So if we are converting this, our voltage, the polarity will be plus minus. Then that voltage will be series to the 4. So I have this there. This one is here. We have this voltage here in series with this resistor. And we have our load resistor, which is the 6 ohms. So we have 6 ohms, 10 volts, 2, 15 volts, 3 ohms, 4 ohms. Now the value of this voltage is equal to I times R, 2 times 4, 8 volts. We also have 8 here. We have 2 ohms. Now let's see if we can add or subtract the voltage sources. You can see these two are in series, right, on the same branch, so we can add or subtract based on the direction of the current. This one, if it is producing current, that current will leave this branch. When this one is also producing current, to move from here. So we can see that those two are producing current in opposite direction, which means we need to subtract and get the equivalent voltage. So we can either say 8 minus 4 to give us 4 volts, or we can also say 4 minus 8 to give you negative 4 based on what you want. So if you are using 8 minus 4, you get a single voltage source there. By looking at that branch, we have 2 resistors, 2 and 4, and they are also in series, so we can find its equivalent, which is 2 plus 4, giving us the 6 ohms there. Good. So let's maintain this portion here and do it in batches. I have this one in series with this one. Then I have our source, the load, the resistor we are working on to find its current. So source plus minus, I have 10 volts, 2 ohms. I have 15 volts, 3. This is source. Now, this 4 volts, where will be the plus, where will be the minus? We are using this minus this. This is bigger than this. So the polarity will be based on the 8. So its current will be moving down, because this one's current was moving down. So we should have our plus, minus, and we have 4 volts. If you are using 4 minus 8, you get negative 4. But you consider the 4 to be positive, it means the result and the polarity there will be positive, negative. So positive, negative, but the value will be negative 4 volts. So let's use this one. Now we cannot add the voltage sources. Why? They are in parallel. Elements in parallel have the same voltage, so we can't get the equivalent voltage in. But then we can convert the voltages to current, because each voltage on each branch is connected in series with a resistor. So we can do the transformation on each of the branches. So let's consider this branch first. You can get a current source moving down because of this plus, and the value of that current source will be parallel to this resistor. You can also convert this to get a current source moving up, and that's current will be parallel to the 3 here. You can as well have this branch current moving up, and it will be parallel towards 2. Then we have our load resistance source. So this is 2, this is 3, this is 4. Alright, this one is 6 ohms. So let's calculate the value for each of the currents. This current is what? V over R, 4 over 6. 2 goes here, 2 goes here, 3. So we have 2 on 3 amperes. The current here, V over R, that one is what? 5 amperes. The current here, V over R, 10 over 2, which gives us what? 5 amperes. Now all the elements are in what? Parallel. And we have current sources too. So current sources in parallel can be added, right, based on their direction. So from here we can get an equivalent current source. But see, these two current sources are moving in the same direction. So if we are using this one to be positive, it means we have positive 5 plus 5. But this one is moving opposite to our choice, that's the current choice. So it means this one will be negative. So 5 plus 5 minus 2 over 3. That will be our equivalent. So let's calculate. 5 plus 5 is what? 10 minus 2 over 3. So our total current there can be what? 28 on 3, which is moving up. Because the 10 amperes here is greater than the 2 over 3. So we have it moving up as what? 28 on 3. And we can also see that the 6 here, the 3 here, and the 2 here. Let's maintain our 6, the load. And let's add 6, 3, and 2 in parallel. Okay, let's maintain our load. So 1 over 6 plus 1 over 3 plus 1 over 2. That is 1 over 6, 1 over 3, 1 over 2 in parallel is giving us 1 over 1, which is 1. And that one is connected to our 6 ohms. So 1 ohm. And we are interested in calculating I naught. So you can guess we are going to use what? Current divider rule to do the division here, get current in the 6. So we are given the total current. It gets to this junction. There is a resistor here, there is a resistor there, it was split. Let's say I1. So we are interested in getting what? I. Or let's say I naught. Let's say I. That is I, current in the 6. So I, using the current divider rule, I is equal to what? The opposite resistor, 1 over 1 plus 6 times the total current, 28 on 3. And this is giving us answer over 1 plus 6 times 28 1 over 7 times 28 on 3, which gives us 4 over 3 amperes. And that's the same as 1 whole number 1 over 3 amperes. So in this question, the current flowing through the 6 ohms I is equal to 1 whole number 1 over 3 amperes. This brings us to the end of our tutorial on source transformation. Thank you very much.